This next video is about op-amp and some signals. Again, let's pick up the op-amp that we have used before, LM741, and let's add power supplies. Now we have the op-amp. Okay, then let's my mouse is not the best possible, to be honest. Let's add 1K is good enough for this one, and the other one could be 2.2 kilo. You cannot use comma here. This is an American software. It doesn't understand if you are using commas, so you have to use dot. Then I'm making some connections. The wire at the ground. I have an inverting amplifier, and the last thing is to add the waveform source. Sine source is the one that I'm looking for. Let's put it here, and I pick up the 1 megahertz model. Here is the amplitude, it means 1 volt. Here's the frequency, 1 megahertz. I think it's absolutely too much. I'm satisfied. A lot smaller frequency, and this is DC offset. You can put this above 0, under 0, so you can just put clearly volts here, like -1 or +1, whatever you want to. Okay, even though our name is like that, it can be a little bit confusing, so we can change the model name to 100 if it's more logical. So let's connect it to circuit 2 and add ground. And then we come to an important point. Always when we are trying to draw some kind of a circuit, this program, the software, is adding node numbers by itself. So we can see the node numbers here. Output is number 3. Normally it depends on which order you are building the circuit, so you cannot too much control the node numbers, but it's not necessary. So output is number 3 and input is number 5. And as we can analyze all kinds of DC circuits with dynamic DC, when we go to this analysis window, it's quite tempting to pick up this or that, but no. In order to get an oscilloscope view, you have to pick up this transient mode. 1 micro is not enough. I had 100 hertz. It should be at least 100 milliseconds, and I don't want to know anything about the supply voltages. That was number 5 as an input. Okay, gonna go back here, and that was number 3 if I remember correctly, the output. I can take them to the same picture, picture 1 and picture 1, or I can take the other one to another picture, to picture 2. This can be auto and run. So I can see that the output is the amplitude is about 2.2 as it should, and it's inverted. Here is the input and here is the output. So with this transient analysis, you can get it quite nicely. And as I told you that this signal doesn't look too smooth, but that's not too difficult to change. I go back to the limits. Maximum time step, let's give it 1 micro. And let's run again, and you can see it's much more beautiful because it's counting more points, but you can also see that the simulation will take a little bit more time. Okay, this is the way how to check how an operational amplifier is working with the signal.